Here we are, we're back with the Math B Fall Finals Notes and Study Guide. This is page 2. Is the relationship proportional given a graph? Remember, there's 2 requirements. That is, the points need to line up in a straight line. Points must line up. And specifically, we should say the graph through the points lines up. And the other is the graph must go through the origin. Graph of line must go through 0, 0, the origin. We call that the origin. This one point's got a very special name. So we have a rainfall that rained 2 inches in 1 hour. Then after 2 hours, it had rained a total of 3 inches. After 4 hours, it had rained a total of 5 inches. Determine whether the number of inches of rainfall is proportional to the number of hours. And so this is where it's, notice this is not labeled for you to begin with, but it's, the language tells us how we should label it. And it happens here. Determine where the number of inches of rainfall is proportional to the number of hours. So here, the way they're saying this, to the number of hours. So this is going to be my number of hours. Is this, is the number of inches of rainfall, is this proportional to this value? So let's label now that we sort of color code it. So this right here is going to be rainfall in inches. Notice here this nice label here. There's what it is, rainfall, and how it's measured in inches. Here we have hours, or it's time as measured in hours. So let's plot points now. It rained 2 inches in 1 hour. So 1 hour, 2 inches. Then after 2 hours, it rained a total of 3 inches. 2 hours, it rained a total of 3 inches. And then after 4 hours, it rained a total of 5 inches. After 4 hours, so 4 hours, it rained a total of, so make sure I stay on the right line here, 5 inches. Okay, the question is, are these proportional? Well, let's see. Let's see if we can draw a line through those. So I'm just going to use my sticky notepad here. Notice when I draw my line, I put my writing implement on one dot. I bring up my tool, and then I sort of pivot it to see if I can get to line up. That looks like it's lined up pretty well. And notice my line, I got through all the dots, and I have to make sure I go all the way through the y-axis. So, oh, I see this note here. Time is almost always on the x-axis. That's very typical, time in x-axis. Well, look, the dots are lined up straight, so that it has our first point, but does this line go through the origin? No, it does not. There's the origin right here. So we would say rainfall is not proportional to hours. That is, there's not a direct connection between the amount of rainfall and the number of hours, at least in this case. Now what they want us to do, they want us to determine the rate of change. The rate of change from a graph. So here's a graph. What is the rate of change here? Remember, rate of change. It's the change in y over the change in x. So let's just pick a couple of points. It's nice to pick points we can read easily. Like that is a point I could read easily. I could use this right here, but see, it doesn't, I can't, it's probably 15, but it's not as clear as this point. And then I have this point, which is, I can also read easily. Let me draw this up a little closer. So now the change in y is I have these 2 points. So what is the change in the y direction? The change in the y direction is this right here. Let's do change of y in yellow. Does that look yellow on the screen? Hope so. So this is my change of y. It's how much up and down there is between this point and this point. And my change in x we'll label pink. So what is the change in y? Well, this y value is 12, and this y value is 6. So this right here is 12 minus 6. That's how, which is 6, which does make sense. So if I start at 6 and I go up 6, 2, 4, 6, these are each 2. So it's a change of 6 in the y direction. In the x direction, it's from here to here. That is, so this was change in y. Change in x is going to be from 4 to 2. So 4 minus 2, or 2. So my rate of change is the change in y over the change in x. In this case, it's going to be change in y was 6. Remember, that's the change up and down over change left and right, which is 2. So does this simplify? Yes. 3. But it's a rate of change. It's a rate. It needs units. And what are the units in this case? Well, I'm consuming meat, right? So it's pounds meat, pounds of meat consumed per person. Stand by just a second. So here's our rate of change is 3 pounds per person. So what are they saying? For every person, they're going to need an additional 3 pounds of meat is consumed. Sounds like the kind of rate of change a place like In-N-Out Burger would want. Here we go, number 7. Interpret the meaning of a point from the graph. So what does a point on the graph mean? Those of you who have been listening carefully, I've been asking that a great deal lately. What do the numbers mean? So often we do calculations, we don't pay attention to what do the numbers connect to? What do the numbers mean? Okay, so that's what they're asking. In this case, it's a point. So they ask, describe what the point 2, 6 means from the graph in problem 6, using one sentence. Consider all the labels. Okay, so here we go. So where's the point 2, 6? 2, 6, right there. So it's this point here. So what does it mean? Well, this point's describing two things, is it not? It's describing the number of people, right? That's the x. And the y is describing 6 pounds of meat. So this one point means 2 people will consume 6 pounds. Notice it's not the rate of change. We're only talking about this one point. We're not talking about this point, or this point, or because this point here would be what? It would be 4 pounds of people consume 12 pounds of meat. This point here looks like one person consumes 3 pounds of meat. Oh yeah, so that dot sort of matches our rate of change, doesn't it? So we want to write it in one sentence. And notice we're using the labels. The label of number of people, pounds meat, and what does this have to do with anything? Well, they're consuming meat, right? So let's say the point, the point 2, 6 means 2 people consume, that's one of our labels, consume 6, I should probably, if I was following the rules of English, I would go like this, because it's less than 10, 6 pounds of meat. So, just so we're clear, when it says to use the labels, consider all the labels, well, there's a label. People, pounds, and consume, right? Those are all the labels. People, pounds of meat. And what are they doing with them? They're consuming it. They're not wrapping it up. They're not delivering it. They're consuming it. Number 8, determine the rate of change from a table. So here's my table. So miles per hour. I notice it looks like this is already set up where if I was to graph this, I would have hours, time here, and I would have my miles here. So this is going to be like my y-axis. This will be my x. So what is the rate of change? Remember, I want to look at the change between different points here. So from 70 to 105 is 35. From 2 to 3, that's 1. So that's the rate of change. So remember, so the rate of change is this, right? Because 70 plus 35 is 105. So my rate of change of y over change of x, 35 over 1. In this case, if I just checked it here, 105 to 175 would be 70, and from 3 to 5 would be 2. If you see, it still works out. 70 over 2, what's half of 70? 35. So my rate of change, remember, it's a rate, so it needs units, 35 miles per hour. There's my rate of change. Write a direct variation equation, and I gave an example, y equals 6x. Use the equation. So I'm going to do two things. I'm going to write an equation, and then I'm going to use it. Y varies directly with x. Remember, this right here is code for direct variation. Like the number of pounds of meat consumed varies directly with the number of people, just like in problem 6. Right? That varies directly. Notice it's also proportional, right? Because it goes to the origin, it's a straight line. So write an equation for direct variation. Remember, that's this right here is code for y equals kx is the way we talked about, where k is my constant of variation. For y equals 60 when x equals 4. So this is an equation of direct variation, and if I solve this for k, I divide both sides by x, and k is equal to y over x. So this is not a, whatever in here is not an equation for direct variation because the y is not by itself. But this is a little equation that'll help me find what the k value is. Remember, your k is your constant of variation. That's what it's called. It's the constant of variation. It's the constant of proportionality. It's the unit rate. It goes by a lot of names. I've run out of room there, so forgive me, I don't write it all the way. So I know if I wanted to find k, I just have to plug in the y and the x values. So y is 60 when x equals 4. What is 60 over 4 simplify to? Well, 60 divided by 4, that's 15. So k is equal to 15. Now what I do is I want to put it back into the form of the equation. So this is k, right? That's k. Hi there, k. 15 is going to go right where that is. Here's my equation. Y equals 15x. That is my equation of direct variation. I hope my writing's neat enough. My R is not very R-like, is it? Use your equation. Use your equation. So what do I mean? Use your equation to find the value of y when x equals 10. So here's my equation. So I want to know what this is, y, when x equals 10. So I'm going to put that 10 right there for x. Y is equal to 15 times 10. Why is it times? Remember, when you have a number next to a variable, it always means multiply. 15 times 10 is 150. Y equals 150. That is the value of y when x equals 10. Okay, there's the second page.